All right. Hi, everyone. My name is Vipul Rahejaz, and I'm an applied research scientist at Grammarly. And today I'm going to be talking about my work on intelligent and interactive writing assistant systems done together with my amazing coworkers and collaborators. So, all right, so to kick things off, let's talk about the writing process to lay down a framework of what people do when they write. So there has been extensive research done on the theory of writing, dating as far back as the 80s. It describes writing as a complex and effortful cognitive task where writers balance and orchestrate three different cognitive processes: planning, translation, and revising. However, contrary to the theory, in practice, the writing process jumps ahead or leaps behind. It's not linear, it's recursive. As we write, we may jump ahead to a later stage of writing process or revisit a prior stage. And this work focuses on text revision as an essential part of writing. It enables writers to deliberate over and organize their thoughts, find a better line of argument, learn afresh, and discover what was not known before. So while text revision is a strategic and adaptive process, it's more importantly an iterative process. Human writers are generally not able to simultaneously comprehend multiple demands and constraints of the task when they produce well-written text. So, for instance, expressing ideas, covering the content, following linguistic norms, and discourse conventions, and so on. So therefore, we turn towards making successive iterations of revisions to reduce the number of considerations at every stage. And this phenomena of iterative text revision is the topic of my research, which I'll talk about today. So with the advent of large language models, similar to the differences that we see in the writing process, the processes and paradigms of writing assistants have also undergone a major shift. Broadly speaking, conventionally, writing assistance has been generally a system-driven or push-based protocol where a user would type their text, the system would evaluate it against some machine learning models and provide a set of suggestions which they could accept or reject. And then this would go on for a few turns until the system didn't detect anything worth improving. But more recently, in addition to the prior paradigm of a system-driven, click-heavy interaction, we have more user-driven systems. It's now more of a conversation with a large language model powering the system, providing a much more collaborative revision experience. This is gonna, all right, I'll try my best. So it's now more of a conversation with a large language model powering the system, providing a much more collaborative revision experience, as opposed to the system providing prescriptive suggestions that the user had no control over. So here you can see that this is kind of a conversation with the writing assistant, where it starts even before a single word in the final document exists. You can see that the user can now provide instructions or input about what needs to be written. The system then generates the first draft, or the user can also write the draft like they did before. And this evaluation proceeds pretty much the same way. But now at the revision stage, the user can either continue revising themselves like they did before, or they could rely on the system to evaluate the revised document and suggest further improvements. If the user chooses the latter, the system could then go ahead and make those revisions for the user. And the interaction then evolves like any other conversational agent, where it's a back and forth between the user and the system about what edits the user wants to reflect in their text. And yeah. And in addition to being conversational, the scope of text editing done by the system is also much more broad, as you can see here. All right. So if we remove the older way of composing and revising text, we are left with this, which, if unraveled through time, looks something like this. And this conversation spans multiple stages of the writing process, right from ideation to composition and multiple rounds of evaluation and revision. And this new paradigm of writing assistance brings with it similar challenges. Challenges around context or history of context tracking, challenges around evaluation, and also challenges around the multi-turn or iterative nature of the writing process. And in reality, while we are quite far from addressing all these challenges to their full extent, we are still in the phase of understanding the writing process and changing the writing assistance process. And in this regard, we have made some progress in the direction of understanding what exactly is the writing process, modeling the writing assistance, and finally, building a system to provide human-in-the-loop collaborative editing. And this is from the perspective of the users being able to leverage intelligent writing assistance better. Okay, so how did we approach these research questions and the prior gaps in prior work? We first created a generalizable edit intention taxonomy for text revision that can be applied across different domains to help understand general human editing. Using this taxonomy, we collected complex text editing data sets and using crowdsourcing across these different dimensions. Using this data set, we then computationally modeled the process using state-of-the-art text editing and text generation techniques and provide insights into the modeling challenges of the task. And finally, we built a human-in-the-loop text editing system to make the revision process more interpretable and efficient. And by analyzing all of these different things and the differences between how humans revise text and how we are able to model the process of text revision, we are able to provide some really in-depth insights about the differences and the challenges that are there to align the two processes. All right, so as part of our focus on the first research question, we started exploring the writing process itself. And in the interest of time, I'll keep this one short and refer you to our paper from ACL, where we propose a taxonomy for text revision based on edit intentions. And we collected a large-scale data set of iterative text revisions in the wild. All right. So we first collected and analyzed thousands of raw documents across different domains. We came up with a text edit intention taxonomy to comprehensively model the text revision process that builds on prior literature. So at the highest level, we categorize the edit intentions into ones that change the meaning of the text and the ones that preserve the meaning of the text. And since our goal is to understand edit intentions that improve the quality of writing, we focus on edit intentions that are non-meaning changing. So we split the non-meaning changing edit intentions into 4 categories. Ones that fix grammatical errors in the text, edits that make the text more concise, readable, and understandable, edits that make the text more cohesive, logically linked, and consistent as a whole, and edits that convey the writer's writing preferences, including emotions, tone, voice, and so on. More specifically, we are focused on non-meaning changing edits, as I mentioned before, and you'll see that these different edit intentions are generally applicable at different domains, different edit intention granularities, which means sentences, paragraphs, and so on, and as well as different revision depths. So we first collect a large data set of raw documents across different domains, Wikipedia, archive, news articles, as they have different writing goals, different writing patterns, different intentions. And for each document, we sorted each version according to its timestamp in ascending order. And for each document, we pair 2 successive versions as one revision. All right. And for each sampled document revision, we extract its full set of edit actions, and then we use Amazon Mechanical Turk to crowdsource edit annotations according to our proposed taxonomy that I've just presented. So again, I'll skim over this in the interest of time, but the takeaway from here is that this gave us a foundation to understand the process of writing, of text revision, to build our system on. So in the next section, I'll cover the various modeling approaches that we explored to model the process using the taxonomy we proposed and the data set we collected. And this will simultaneously address the next two research questions on how we modeled the process better and how can we build writing assistant systems to be much more collaborative and efficient. So when it comes to modeling the writing process over time, we've seen three distinct patterns which form the body of our work. And these are called system-driven, user-driven, and mixed initiative writing assistant systems. They mainly differ across three different axes. The first one is interaction, where defined as who out of human and machine drives the revision interactions. Second one is revision, who out of human and machine performs the revision. And finally, evaluation, defined as who out of human and machine evaluates the quality of the revised text and drives the next step in the interaction. So, all right. So I'll dive into the first work called Deliterator, which was from EMNLP last year, which is primarily system-driven. So here is a bit more detail on how we model the system-driven writing assistants. We propose a two-step approach to text editing where we first perform edit intention classification, where we predict the spans that need revision and the type of revision needed by the edit intention, which could be one of fluency, clarity, coherence, and style. And then for the predicted sentences or spans that need revision, a text revision model makes the actual edits, leading to a new document revision. And here we see a given document with, let's say, n sentences. We take a context window of k sentences, let's say k equals 2 for now. We first predict the spans that need revision and the type of revision needed. And then for the predicted sentences or spans that need revision, a text revision model makes the actual edits, leading to a new document revision. And this process, as you can see, repeats itself a few times till the system decides there are no more revisions left to be made. All right. So now I'll cover the next part of the work where we explored large instruction tuning with large language models, which is the other end of the spectrum, where we gave full control to the user to drive the revision process. And as you can see, over many iterations, the revision interaction, the revision itself, and the evaluation, it's all driven by the user. The system is sharing the main responsibility of only making the revisions. And then if we look at the system here, in the same way as I described the previous systems, you can see that here the revision interaction, the revision itself, and the evaluation is all driven by the user, where one can argue that this is the other extreme from being mostly system-driven in the previous one to mostly being user-driven here. And due to the conversational nature of the process here, it brings with it similar challenges of data, context management, evaluation, and so on. Okay, so now we finally come up with CTRLHF, which is collaborative text editing with reinforcement learning with human feedback, which tries to address the limitations of both the previous systems pertaining to interaction, revision, and evaluation. Okay. And as you can see here, every stage has both human and machine responsible for driving it. So it's a much more collaborative way. Neither of the extremes are going on in this one. And if we look at it in the same way as the more simplified version of CTR-LHF, given a document in the revision cycle, could have been created by a human or in collaboration with a text generation system, we replace the predominantly user-driven interaction with something that is both user-driven and system-driven, so much more collaborative way to decide what to revise and how to drive the revision process. All right. So in the next section, I'll present some results pertaining to the modeling and human-machine collaboration. So here, across our modeling and human-machine collaborative writing explorations, we observed that while instruction tuning has been incredibly powerful to improve the quality of revisions, RLHF training is able to improve it even further, and especially along the more subjective criteria such as style and coherence. And in contrast, we also conducted experiments against ChatGPT, and while it's able to outperform our systems on style and fluency tasks, it lacks much far behind on coherence and clarity, which can be attributed to the verbosity or more, the system taking much more liberty in terms of what it's generating, which could be good for paraphrasing, but not so good when it comes to very well-defined goals such as correctness or clarity. And at the same time, our models are able to do this while being much smaller than ChatGPT. So yeah, I'll refer you to the paper for all the details. Secondly, we also conducted qualitative human evaluations by asking qualified users to use our system for iterative text revision using different models at the back end. And they were asked to provide ratings on 0 to 3 for every revision depth for 50 documents. And as a baseline, we also asked to rate the quality of revisions made by humans, which were basically our reference set. And we found that in terms of human evaluations, the ratings were in line with automated metrics, where CTR-LHF did better than Coedit, which did better than Deliterator. However, ChatGPT scored quite close to CTR-LHF, which was better than the automatic evaluation. So this indicates the limitations of automatic metrics, and there's a dire need to build better document-level evaluations for text editing. So we also shed some light on the behavior of text revision systems by iteratively applying this system to a set of essays. So on the left, you see that we have edit intention trajectories of the system, which is applied to make revisions on the essays written by students with an intermediate or low level of English. Whereas on the right side, we have a similar setting, but essays are written by students with good command of English. And you can see that the system makes fewer revisions for fluency on the essays written by the second group of students, which gives you an idea of how it helps with effective writing for people with various kinds of writing assistance needs. And thanks to human preference learning, the writing assistance systems are now much more contextualized and adaptable, and this opens up new opportunities for more personalized writing assistance. So we also measure the efficiency of the mixed initiative system by removing the human interaction from our system by asking, again, 3 qualified annotators to evaluate the quality of our system. And this gives us the system-only baseline, where annotators were asked to judge whether the final revised documents have improved quality or not. And it shows that human-machine interaction helps produce a higher quality of revised documents with a fewer number of edits and fewer iterations of revisions on average. And this validates the hypothesis of the effectiveness of human feedback in the text revision process, which can help filter out noisy edits and improve the quality of the final revised documents. One interesting insight here is that the mix initiative setting led to a slower revision process that you can see. And that means that while the amount of work has been reduced, it still made people slower as they had to evaluate the system's suggestions a lot more. All right, so to sum it up, I thought I had gotten the hang of it. Okay. Yeah, sum up. We tried to improve the systems along 3 different dimensions. The first one is quality. Our computational modeling of the process has progressively gotten better, owing to the advances in text generation, as evidenced by our qualitative and quantitative evaluations. We find that human-machine collaborative system revisions work much better than any other alternatives, which either skew the control of the interaction revision or evaluation to either the user completely or to the system completely. And finally, while collaborative revision improves the quality of writing, it also leads to slower revision, which is, can be counterintuitive, but that's what we found. All right. Okay, so in terms of future work, we aim to improve the contextualization of our systems to make and have them provide better suggestions for different users and different writing needs. We hope to invest some of this effort in formulating better evaluation frameworks, which we saw that automatic metrics are just not good enough for evaluation relative to human metrics. And finally, we aim to improve this human-in-the-loop writing process by learning to provide the most effective and efficient suggestions. And finally, I'd like to leave you with some examples of how we are leveraging this research in the Grammarly product. And both of these are generally available. So this is Grammarly Go, Grammarly's GenAI offering, which has been out since April. So it helps you compose, reply quickly, revise quickly. And as you can see, it's a very collaborative process. Both the user and the system are in control of how to drive the process further. All right. There you go. And second one is a version of this on mobile, where we leverage speech as a user's input to articulate what they want to write about. And we give them the ability to compose and edit documents, messages, and notes, and so on. All right. So that's it. Thank you so much, everyone, for your attention and your patience.
Hi, I had a question. You spoke about, let's say, determining quality for the end, like revised text, right? How do you determine how that affects business outcomes? How do you evaluate the impact on business outcomes? Because it can be somewhat subjective, right, for your end users?
Yeah. So these are different things. I think for the text revision models that we develop, there are very task-specific evaluation criteria, test data sets, evaluation metrics. So, for example, for grammatical error correction, if we build a model, there has to be an intrinsic evaluation targeted towards something along the lines of, was the text corrected in the test set? Or let's say for simplification, did the readability of the text improve? Or for paraphrasing, was the text, the paraphrase text different while preserving the meaning? So I guess these are basically task-specific evaluations, but the way people, when people use the product, yes, they have very different writing goals. And that is something you can think of any online evaluation, something like engagement metrics would be how to, we would track the impact of such, any change that we make in these models, yes, how did any of the engagement metrics change? I think that's kind of how we would do it. Did that answer your question? Okay.